leprosy, actinomycosis. Then there are some parasites. The example is schistosomiasis, spirochete infection, spirochetal, that causes syphilis, and the spirochetes are trypanosomes, and some of the fungi, again aspergillosis, Cryptococcus, candidiasis, and histoplasma. All these can cause chronic specific inflammation. So that was about infections. Then we come to essential components of granuloma. This is very, very important. Granuloma consists of which components? Number one, macrophages. When these macrophages, you can say they are either modified or activated macrophages, and when they are present in granuloma, they are named as epithelioid cells. So their epithelioid cells are nothing but activated macrophages. As you can see here, epithelioid cells, they are activated macrophages, slightly elongated in shape, and they have slipper-shaped nucleus. The other cells surrounding the epithelioid cells are lymphocytes, which are shown as round cells. Here in the diagram, they are shown as round cells. They are lymphocytes. The next are the giant cells. In this diagram, you can see just one giant cell, and that is Langerhans type of giant cell, which is again common in tuberculosis. Then necrosis, and last is fibrosis. In the center of this diagram, you find this colored area, that is necrosis, and that is caseating necrosis. You very well know the different types of necrosis, and in this granuloma, especially it is caseating type of. Surrounding all this, the presence of fibrous tissue which forms fibrosis. Okay, surrounding all the almost 3/4, or you can say 80% of the granuloma. Then last cover is of fibrosis, which is made up of fibroblast. So this becomes important or essential components of granuloma. Again, you can see the colored diagram, which makes you very clear which are these 5 components. The first one, you never forget, it is epithelioid cells. So these light bluish color are epithelioid cells. Okay. Then dark blue colored round cells are the lymphocytes. Then on one side, you can see the giant cell, and that is Langerhans, which is here slight pink in color. In the pink center is the pink area, which is caseous necrosis. Here we have very well mentioned caseous necrosis on gross examination. So if this is a tissue, then you can in the form of whitish to yellow colored area, that is on gross examination. This one is a colored diagram. So that is why it is pink in color, as it takes up pink color on HE stain. So central necrosis, that is amorphous eosinonuclear fibritic material with complete loss of cellular details. So hardly you can see any cells. It is totally destroyed, and it is present in the form of necrosis. So that was granuloma. Now all these cells will be studied in detail further. We have seen epithelioid cells. They are either activated or modified macrophages. What is their origin? What is their structure and function? So they are named by because of their appearance, but are not in fact epithelial. Remember, just the shape is similar, but otherwise its function is not like epithelial cells. But the structure is like epithelial, it is named as epithelioid cells. And originally they are macrophages, activated or activated macrophages, and they are derived from blood monocytes. Remember, when they are in blood, they are monocytes. When they are in tissues, they are macrophages. Now we will see to the structure, origin, we see the structure. On the right side, you can see the microscopic view of, high power view of the tissue which contains these. So light colored cells are all macrophages. They are somewhat elongated, pale staining, abundant cytoplasm, vesicular nuclei, and light staining slipper-shaped nucleus. I don't know whether you'll be able to appreciate slipper-shaped nucleus here or not, but I will show you one video where you can appreciate it very well. Slipper-shaped nucleus of epithelioid cells. And that is vesicular and light in color. They have cytoplasm that is pink in color, and cytoplasm is abundant. Now these epithelioid cells, they are less phagocytic than other macrophages and appear to be modified for secretory functions. The next cell after epithelioid macrophages, the important cells are giant cells. They are modified macrophages and are formed by the fusion of adjacent epithelioid cells, and the nuclei in these giant cells may be more than 20 or more than 20 nuclei. The size of the giant cell, individual giant cell, they have diameter of 40 to 15 micron in size. They have large mass of cytoplasm containing again nuclei 20 or more small nuclei. Now this is one type of giant cell, that is Langerhans giant cell, which is very commonly seen in tuberculosis. And the nuclei, that is about 20 or more nuclei, they may be arranged in different way inside the large cell. Or at the periphery, just like a ring form, or clustered at the two poles. So Langerhans giant cell, they are characteristic feature of tuberculosis. We see here the microscopic view of the tissue which contains different giant cell. We have already numbered, and remember, first of all, these Langerhans giant cell, they are formed by fusion of epithelioid cell, and the nuclei are arranged in different form. First are periphery in the form of horseshoe. So here you can see number 1 as horseshoe shaped nuclei arrangement in the Langerhans giant cell. Number 2, peripherally in the ring form. So at the site of the cell wall, just below the cell wall, the nuclei are arranged below it throughout the circular fashion. So that is second arrangement, and this arrangement is known as ring form arrangement of the nuclei in Langerhans giant cell. Number 3, foreign body type with centrally placed nuclei. So all the nuclei which are present in a single giant cell, they locate the type of giant cell. And the last is when the nuclei are occurred at 2 poles. This one is a giant cell and either at the north-south or east-west pole. So the opposite poles, they have the presence of the nuclei. So that is why arrangement of nuclei at 2 poles. So in Langerhans giant cell, there are different arrangement of the nuclei in the form of horseshoe-shaped, peripheral type, and last is clustering of nuclei at 2 poles. Again, a high power view of a single giant cell. Who me what is the arrangement of the nucleus? Arrangement of the nuclei. There are 4 types of arrangement which we have seen in the previous slide. Now you tell me which one is this arrangement. Very simple. Peripheral ring shaped, correct? Very correct. So it is ring shaped nuclei. Okay, next. Now we come to necrosis. Necrosis also is a very important feature in granuloma. So it is a feature and that is mostly in the center of the granuloma you find necrosis, and very typical of tuberculosis. So it is so called because of the cheese-like appearance and consistency of necrosis. I told you earlier that on gross examination, caseation necrosis is very evident, and necrotic tissue, it is known as cheese-like appearance because of its color and consistency. Consistency is very soft and color is yellowish white, just like cheese material. Next, the last component of granuloma is fibrosis. So here you can see this one G is granuloma and fibrosis colored thread-like structure. We can see this one is a label, blood are all surrounding the granuloma are fibrotic tissue. So fibrosis here is due to proliferation of fibroblast at the periphery of granuloma. Similarly, a stain slide. Now you can see dot colored blue